Alright, so today's lesson is going to be a little bit about the vapor compression refrigeration cycle itself. The cycle itself, as you can see on this particular diagram, is pretty simple, honestly. And what you're looking at is starting with the compressor here. I got my little pen tool up, so I'm going to show you that. So this is the compressor. Now the refrigerant's flowing throughout the system in a continuous cycle, continuous loop. So we're seeing our hot gas refrigerant leave our compressor and go into our condenser. Now this is important because if it weren't a hot gas, it's not going to actually condense when it gets to the condenser. It also needs to release heat, heat that was actually picked up over here in the evaporator. So that's an important function of the condenser. There's actually three jobs that are going on here. When the hot gas first goes into the condenser, we're seeing it de-superheat first. And then we're seeing it start the process of actually condensing. And when it becomes a liquid, any temperature that it's actually cooled past its boiling point is known as subcool. So that's the third job of our condenser, is to subcool our refrigerant. So there's three processes going on here: de-superheating, condensing, subcooling. Alright, so we're going to leave the condenser as a liquid. We're still under high pressure, still relatively high temperature, though most of our temperature has been released from the condenser. So normally what we see coming out of the condenser is probably 90-degree refrigerant. It's not really warm, but it's still warm, relatively speaking. We go into the liquid receiver, and this is just a can that holds liquid. You see this dip tube that goes down to the bottom of it, and that's by design as well. So we see that dip tube going down to the bottom. Hopefully it's picking up liquid refrigerant off of the bottom of the receiver. The receiver can also be thought of as kind of a storage tank. It's going to store excess refrigerant when the system actually doesn't need it. The only time it needs that excess refrigerant is typically when it's going through a hot pull down phase, which means basically if you bought a brand new refrigerator, you take it home and you crank it up for the first time, guess what? The interior of that refrigerator is going to be hot. And that machine's going to struggle to pull the temperature down right at first. It needs some excess refrigerant to do that. It's not designed to run under those conditions. So in order for that brand new fridge to be plugged in and for it to cool down, it's got to have some excess refrigerant to do it with, and that's what the receiver provides. Now we go down the liquid line of the system, and you can see this little symbol here. I'm going to circle it. You see that little symbol there? That's actually a sight glass. That's what it's meant to represent. So we're going to go on down the liquid line. Should have liquid refrigerant coming into our metering device here, and then the metering device, what it does is the opposite of what the compressor is actually doing here. So the metering device is expanding the refrigerant. It forces it through a little tiny orifice, all this liquid, this warm liquid, and when it goes through that little tiny orifice, we get a spraying effect that happens that sprays the refrigerant into the evaporator. Now, if you've ever done any spray painting, or ladies, if you've ever used up an entire thing of hairspray at one time, you'll notice that the pressure in the can actually drops as you're releasing the product from that can. Now, the same thing's sort of happening here in our metering device. As the refrigerant's going through it, it's spraying it into the evaporator coil, and it becomes incredibly cold. It also drops the pressure in the evaporator. So as our pressure in our evaporator is falling because it is spraying refrigerant into it, depressurizing that refrigerant, we're going to see it boil off. And what's actually entering our evaporator, unlike with their condenser example up here, it's not just a liquid. Okay, when this metering device sprays that liquid into the coil, it's going to separate some of it into a gas, and that's what we call flash gas. So that 75-25 liquid vapor mix is what's going on here. So 75-25, mostly liquid, but some vapor, and that's going into your evaporator. Now we want that 75% liquid to boil off, and that other 25% vapor is very cold. So that's gonna help our evaporator out when it comes to actually cooling the air that's flowing across it. So now we're going to go across the evaporator. There's not a whole lot of jobs that are going on in here like the condensers. Three jobs associated with condenser. Really, with the evaporator, there's only two. Its job is to boil off that 75% liquid, carry that 25% vapor on through for the cooling effect. And then when we get toward the end of the evaporator, we want a little bit of superheat. We want it to be warmed just a bit beyond its boiling point, just to guarantee that it's a vapor. And the reason for that is because compressors don't like liquids. Okay, liquids are not compressible, vapors are. So the ultimate thing here is just, the ultimate concern is to keep the compressor from sucking in liquid. So we've got this vapor refrigerant coming out of our evaporator. It should be relatively cold. And it's going to dump into top of our suction accumulator here. Notice this dip tube here doesn't go all the way to the bottom of the tank, and that's actually for a reason. This tube here actually does, but it comes back up to the top and is picking up vapor off the top, sort of like that. And there's sort of a reason for that. We don't want liquid getting in this compressor. This acts like a liquid trap, in effect. So it's dumping refrigerant in. If any liquid gets in there, it's going to fall to the bottom of the canister. And this tube actually picks up its suction from the top of the canister. So it's impossible for this canister, unless it gets completely filled with liquid, to give the compressor any liquid whatsoever. So that's a tour around the refrigeration system. Hopefully you got an idea of what was going on. Hopefully this video wasn't a little too long. I like to keep them bite-sized if I can. I'm going to erase this ink here so you can see what's going on. Once again, want to pay particular attention to this high to low pressure dividing line. Anytime we talk about the low side of the system, that's what's over here. That's the low side. This is the high side. And that dividing line is going to go across the compressor and the metering device, because that kind of marks the beginning of the high side over here on the compressor. That's the beginning of the high side. This is the beginning of the low side. So that's why we draw that line through there, just to separate the low and the high side. Also, we have actually a gas side and a liquid side. So see down here where this liquid line is, obviously that's your liquid side. And up here is your vapor side. So the vapor tends to exist on the top end of these diagrams, where liquid exists on the bottom end of these diagrams. That's something you won't see actually notated in this diagram, but something that I do like to teach, because it can help you. Just remember, high and low side. If it's a vapor, it's got to be between the evaporator and the condenser, somewhere around the compressor. If it's a liquid in the system, it's got to be somewhere in between the condenser and the evaporator, or in between. So get those ideas, nail those down. Watch this video a couple of times if you need to. Otherwise, thanks for watching.